If you're watching this video on YouTube, you can watch on 1.5x speed. So today we are going to see the Leetcode question, and that is we have 438. So question number 438, we have to find all the anagrams in a string. So let's read the question. We have given to a string s and p. We have to return an array at all start indices at p, indices of p anagrams in s. Okay, you may return the answer in any order. Let's understand what is anagrams. So anagrams is a word or phrase formed by rearranging the letters of a different word or phrase. So typically using all the letters, original letters exactly once. Okay, so let's suppose we have example. Let's suppose we'll take first example 2. Okay, that is a small one. So in the this we have a p is given, a and b we have given. Okay, and in the s we have given what, AB we have given. Okay, so this is a smaller one, so we are taking this one. Now see, is AB is available in this, right? So if I'll go to the index here 0, we can see we have A and B after that, right? A and B we can see here. Next time I'll go to check from here index number what, 1. Yeah, we have BA, right? So BA is also uh, anagram, right? And if I'll go to next position at 2, we can say yeah we have AB, right? So we can say we have AB also. So at index 0, at index 1, at index 2, we are getting the anagrams, right? And that's why we have the output 0, 1, 2, right, as a output. Similarly, if we'll talk about this one, right, we have given this one string and ABC in the P. So if we'll go to the index 0, right, you can have CBA, correct? And if you come to next index 0, 1, 2, 3, 4, 5, and next we have 6, right? So at 6 we have what? We have 1 minute. We have BAC, right? At index, this is at index 0 and this is at index 6, right? So you can see in the example 1, right? So you can find the anagrams ABC. We have to find ABC in the string s, right? And we are getting at 2 indexes, right? 0 and 6. So you can say that we can return 0 and 6, right? So I think you have understood this question, right? So we will continue these questions to make this, right? So make sure that this question has been asked in the FANG. So this is very important questions, and please watch the full video so you will understand in the depth. So we are here at the browser section, right? So we will try to implement this one, right? So see, this problem is a multiple pattern we have for searching this string into another string, right? So all such problems usually could be, you can say, by you can solve by using a sliding window approach, right, in a linear time. So the challenge is here is how to implement the constant time slice to fit into a linear time. So what we will do, if the pattern are not known in the advance, then what we will do, we'll try to find the duplicate problems, and one could do by doing what, two ways to implement that one. Either the constant time slide, or either we can use bit mask that we have already seen. Another I'll put the link in this video, okay? So bit mask or Robin curve. So please check at least these approaches, right, and try to implement this one. Okay, so I'll put all the links in this video. I have already developed this type of question. Okay, so here's the situation. The most, you can say, more simple and patterns are known in intervals, and the set of characters in the pattern is very limited as well. You can say we have 26 character, right, letters in the lowercase we have letter in English, and so that what we will do, we will hence we can say, so one could allocate array of HashMap with the 26 elements, and then we will use letters to count, to letter count, right, to do the sliding. Okay, so I think you are already aware with the sliding window, right? So we use sliding window with the HashMap. Okay, so first of all, what we should do, we should start from the simplest approach, the sliding window plus 2 counter HashMap we will take. will take a letter will take, and letter you can say, or its count, right? And the first hash map is reference counter. You can say we will take some counter, right? For the string p, we'll say string p count, and we'll take one another second counter, and that is was we can say string counter, right? Is, and we'll do the sliding, right? So the idea is to move the sliding window along the string s, and we will recompute the second hash map. We can say we have p count, we have s count, we have, so we'll do that, right? So s count in a constant time we have, and we will try to compare the first map, right? So I will check if the both count for the string s and p is equal. Then what we will do, we will say then string is in the sliding window is permuted of a string p, right? And one could add it at a start position, and in the output list we will put a letter. Okay, so what we can do, if you'll do the summarization, what we will do, so first we will build a reference count for p and you can say s, right, that we have given. So and then we will try to move along the string s. So better what we will do, recompute with the sliding window each time on the s count. At each step we will try to add letters on the right, and we will remove from the left, right? And we will check also if count of s and p is equal, then then we will update our list. Finally we will return our list. Okay, so let's go to the here, and we'll try to implement. Okay, so I'll start from here. So first of all, what I told, we have to take two variables, right? So let's suppose we have s, we have given, right? S we have given. So I'll take the length of s, that is length, right? And this is a string, so we'll say the length is n underscore s. Okay, so this is the length of string s. Okay, then we will take its we can say length of another one, right? Another we have length of, you can say p, and that is p dot length, right? Okay, so now we have the length of both. Okay, now we should do what, we will check the we should take maps, right, for each one. So what I will do, we'll take a hash map, right? So I'll take p hm dot count, so we'll understand. Okay, so this is the hash map for p. Okay, and we'll take new hash map. Okay, so this will store the character and its count, right? So we have to define, this is a map, and we'll take two things. The first, it will take integer, yeah, sorry, no, not integer, it will take character, right? So first it will take character, and then its count, right? Integer. This similarly we'll create one more hash map, and we can say this hash map is for s, right? Two string we have, and we have two hash map we have, right? So actually we are going to do a sliding window with a hash map, sliding window with two hash map, right? So what we will do, we have our two now maps that we will try to do what, we will take one each character, and we will update its count, right? So if you understand this question, you can pause and you can try by your own. Okay, now what we will do, we'll try to build the reference hash map using the p, right? So how we'll do that, we'll do for, and we'll say for each character we'll take from what, p dot 2, we can convert into character array, and for each character array we can get from what, one character. So we'll take character, we'll say c. Okay, this is our each character we are getting from the p, right? And for each character, what we will do, we'll check on this count, right? We have the map, right? If that is available, so we'll check if this count has, right, contains key, right? There is a function contains key on the map. We'll check our character. If character is there, then what we will do, we will update its count, right? So this one dot we will put again, and we'll say the character that we have, see, we will increment our count. We will get first, we'll get this its current count, that is current count is nothing but what we will get from this passing the C, and then we will increment 1, right? So we will have our latest count for this character, correct? Similarly, if we will not have on the HashMap, right, then we will simply uh, put this, we can pass this one, right? We will pass this one, but we are not going to add one on that. We will pass just one, correct? We'll pass this count like this. Similarly, what we can do, we can do for you can say another one, right? But what we will do here, we'll take we'll check, we will take first output, we can say, so that we will add each time. Better what we will do, first we will go for all the we will slide the window on the string s, and we'll try to find, okay, this p. Okay, so let's how to slide the window on this string. So we'll start from index I, that is from the 0, right? For each character, we will check from the each character we have the p or not on this value, right? So we will go to till length of a string s, and then we will go to the we can say plus plus, right, I. Okay, now what we will do, we will try to add each letter right on this one, and we'll uh, move to the right side, right? So how we'll do that? So first of all, we'll check the character at that position, right? So we'll check character at what we have I, right? What is the character at this position? So let's assume this character is nothing but char C. Okay, this is the character we have. Okay, and then we will check this character on this what our we have let's suppose we have, if we'll do uh, where we can find this one, right here. If this count contains, right, if this map contains key, we'll pass C, correct? You can directly pass at this one also. So if this is at this position, right, then what we will do, we will update its count, right? So we have our S map we have, and then we from here we'll check, we'll update, sorry, we will put here that this character we have already moved, right? This character we have already moved, we have already checked, right? And then we will put our count, correct? So on this we will first get similarly that we have done for the above, and we'll update plus one, right? Now each time we are updating our S map also, right? So our S map is getting updated, right? And if we don't have right here, then what we will do, simply we'll take like this that we have done previously. We'll take this one, and we are not going to update each time. Okay, we are not going to update each time, so we have to remove this part, correct? If that is available on the key, then we will do, otherwise not. If not, then we will pass only one. The current count is will only one. Now we have to remove one letter from the left side of the window. We have to try, right, one by one. So for here, let's suppose we are at this position, okay, and we have already added, right, here. So what we will do, we will remove one letter, and we'll try to move to from left side of the window. Okay, so I'm talking about this one. So what we will do, first of all, for I, if I is what, greater than equal to, sorry, greater than equal to n underscore p, correct? We are at greater than this one, length of this one. Okay, then what we will do, we will check the character we have equal to what, s dot caret, right? S dot caret, and what we have, I we have already, and we'll do length of p. We will check. So I minus length of p, we will have our character. Directly we will check this one that we have already have on the s count, right? So on s hash map we already have this one. On this map we will check what, get, and we'll pass our character, and if character is have on the map, and that is count is 1, then what we will do, we will check from the s map, right? From the s map we will remove, right? This character we will remove if that is there. Similarly, uh, once we have, right, then what we will do, we'll do that, we will remove from the map, and then uh, we'll try to count again, right? So in the ends we will update our count. So what we will do, we have s count, right? S count map we have, on that we will put our character, and another is what, we have on this one also, on the map we will get our current count, right, for this character, and we'll do similarly +1, right? So why we are doing this one, because we have to remove one letter each time, right? And then we will move to the next, right? So for that what we will do, we will get the character and we'll check on the string count, and then we will try to do again. Okay, so these things we have updated. Now what we'll do, once our character is done, right, then we will come to our this f, and then finally what we will do, we'll check, we'll try to compare the hash map in the sliding window, and we'll check the reference of the hash map, right? How we'll do that? First we will check if the we have hash map we have already for the p, right? We'll check the, we'll do the equals, and we'll try to find the count we had for s count, right? We'll check both. If both are equal, p hash map and s hash map are equal, then what we will do, we will take one output, okay, and we'll add on there, right? So we have to get our output, right? So what we will do, let's suppose we have output we have, and then what we will do, we will add on here, and we'll say first we will pass the I minus what we have, n underscore p, right, length, and then we will pass our we'll do +1, sorry, we'll do +1, right, each time. I minus np, that we have already seen, I minus np, and then what we will do, we will increment +1, and finally we will return our output here, return out. So what is output? So what we have to do, from here, once we will reach that, right? So here we will update our output. So output we have to take in the list, so it is nothing but our integer to store the indexes, right? So we'll have our out equal nothing but our array, right? Array list. Let me summarize and we'll check, right? So we are going to do sliding window, so we will take two hash map. First we will check on the p map, and we'll check if the element is not there, so we will update each time the character and its current count +1, right? If the character is repeating, we'll update its count, right? We will +1. Similarly, what we will do, we are taking on one output, and we will update its index each time on this list, and we will return that one. That we are doing here. What we will do, first, if the count for p count and h count is matching, then we will update and we will return the index, right? Now for all characters of the map of s, right, what we will do, we'll check the character is we have on the s, then we will update +1, otherwise we will do plus, so we'll do only increment in increase, we will put into the map, you can say. If already on the map, we will increment by +1. If not, then we will put into the map. Then we will check if the I index is greater than what P index, right? Means we have reached the last, right? Then what we will do, we will take the character at this position and we'll check onto the S map, right? If that is equal, then what we will do, we will remove that character from there, and will not, if not there, then we will update our string count, another count. And then what we will do, we'll do and we will plus do will here. Okay, so let me try to run this one. Okay, so it is saying P string length. Okay, see, we are updating here. Actually we have to remove this one, right? So we have to remove. Yeah, this will work. So what we have did here wrong, that we were updating, actually we have to remove, right? And that's why we are removing from here, right? So if we have to we have already found, right, if that is already there, right? So what we will do, we'll do reduce its count now on the S count, right? We don't have now that character on that one. Okay, so let me summarize this one, and we'll try to see through the example, and we'll try to do that. Okay, so let's suppose we have P have what we have A, B, C. Okay, and what we are doing, we will do we have our two things we are taking, right? So we have this one. Let's suppose we have P, H, M, and we have our count. Okay, so this is nothing but means what we have P A, then we have B, and then we have C. Okay, so I'm mapping this one like this. A is have one count, B have one count, C have one count, right? Now we have what S, HM, and count, right? This map. So this map is containing what? Let's suppose this is also we have initially we have A, B, and C, correct? So yeah, like this. Now what we have, 1 1 1, three element we have. So both count we have, HM count we have, right, and SM count we have, right? P count and S count both we have, right, in the map. Now what we will do, let's suppose we have a string, okay, S, and a string S contain what? C, B, A, E, B, A, B, A, C, D. Example first, right, that we have already seen. Now what we will do on this example, we'll check the first this character. Okay, we'll start from these three, C, B, A, right? And this you can see that we are able to the first three character we have here, and it is mapping. So what we will do, on the output we will add this index, because at this index we have got our starting index, we will put onto the map 0. So we have updated because we got the same HashMap, right? So HM currently we are starting from here at index 0, right? And then we will move to the last length till the end, let's suppose. But our HM we have got what? ABCD we have already got, right? And so we can say that this ABCD we have got here, and we will update this one, because these and these both are now same, correct? Now what we will do next time, we will increment our length. So when we will reach to this length, let's suppose I'll give me 1 minute. Yeah, so next time what will happen, if I'll come to next position here to here, so you will see this E, right? This is our E, and that's why this is not matching. Both are not same now, right? So if not same, we will not do anything. Similarly, we'll do for the next, right? We'll go to the next element from here, right? We are here, right? We'll try to see this one, A, E, this one. Yeah, this is also not match. Next we will move to this element, EBA. We are not seeing this one, right? So now we will move to we have checked, right? Now we will check this one will not match. Similarly, we will go to check these three, it will not match. Now when we reach here at this position, we'll see again what BAC, right? What we will got there, BAC we will got at that position, and so that we can say these three BAC at this position, right? We have got our next one, and this will become same, right? So next time what will happen, we will reach at this position and we'll say we have got our next map, right? Next value we have match the same. Now we will update our, this with the 6. Why? See, 0 1 2 3 4 5 6 at this position we got again. First we have got at this position, and second we have got at this position, so we are getting there. Okay, and now you can see that I have taken one HashMap here, P map, and another we have gotten S map, right? So what I'm doing here, we are doing character C P dot char at this one, and hm dot count contains key, right? So what we will do here, or at each count we are passing what, C, right? And then we are passing what, we are updating its current count plus 1, and if that is not available on that count, we are updating its count plus 1. We will put the first time it is coming, then we will see count is 1. If next time counting, we will update count plus 1. That is understand, right? Next, similarly, we each time we are updating our output, that we are coming here, this output is coming 0 and 6. So we are checking what we are checking here, we will check this one, right? So character at, okay, character at what, I minus np, right? We will get. So if we have the element, right, then we will do what, minus 1 will do, okay, each time, and we will update our, we will remove the hm count, we will remove, and similarly we'll update our count with minus 1 each time, and then we will do what, we will add I minus np plus 1. So see why this is doing, we are doing, let's suppose character we have at s, right? This one, that this one. So char at this is what, we are at I at this position, let's suppose this is I, okay, and np we know that, right? Length of p is abc3, right? Then we will do, we will reduce that length, right? From that position, you can say, if that we are at that position, and we'll check the all the character, and we will try to remove this one, okay. hm dot count, we will remove, first we will remove these, then this, then this, we will each time we will remove for all the I, and if we'll get, if we'll remove that one, means we have our exact count we have, and after that we don't need to do anything, just we'll check all our count. If both count is matching, right, this count is matching and this count is matching, if both are matching, then we will update I minus n of length p, and plus 1 will do, and we will got our output. I think you have understood. If not, please ping me in the comment box, I'll try to help there. Okay, now if we'll talk about the complexity, right? So we have, let's suppose what we will do here, yeah, I'll try to write here. Okay, so let's suppose what we have here, so let's suppose we have length, we have taken this one, and length we have taken this one. Okay, so length of this is s and p we have. So let's, k is the maximum possible number of distinct character we have, total distinct character is k we have. So in this problem what we will do, total, let's suppose we have k is equal to 26 later, because s and p consist of what, in the lowercase in the English, right? So what we will do, time complexity for the first one, we will suppose we have the length, we are talking about the string, right? So this one, right? So if the length is this one, right? So what we will do, this is O of n s, we can say, for the string, for the time complexity, right? Because total we perform in one pass, each string n of s is greater than or equal to p. So which is the cost of, we'll add this one and O of n p, we can say, right? So if we'll do the sum, we will get what, O of n only, there's the length of s only, right? And so because n of s is always greater than or equal to n of p, and so this will be our output O of n and of s, right? And if we'll talk about the space, we are taking what uh, each time we will take these two count we are taking here, two maps we are taking, right? So for the count map, right, two count map we will have will cost a most k element we will have. So for each k, that is a fixed size of 26, that will maximum, right? So what we will do, it will consider the space of O of n only, right? But we have total k number of element we have, right? So we can say O of n for 26 later, right? And this will take each time O of 1. So if we'll do this, multiply these two, so we'll get what? Total element is k. K is 26, right? And so we will see that O of k, that is our number of elements in the string we have. Okay. So I think you have understood. If not, please ping me in the comment box. Thank you so much, guys. If you have any question.